Yeah, my task is to talk a little bit about the Red-Pitaya as a measurement device and an SDR system. And I want to, oh, is it working? Yeah. The Red-Pitaya technology should be introduced first. The Red-Pitaya is an open source development by Pavel Demin, who's a Belgian scientist at University of Leuven. He did most of the work we as a ham can use for SDRs applications. Well, the Red-Pitaya is a measurement system, and I can show you a little bit about the measurement system. And of course, the radio application from 0 to 60 megahertz. And I want to introduce some of the community projects. The development of measurement system is in the past. We throw out the analog measurement instruments, and they are replaced by, instrument. The instruments are replaced by measurement systems. So the spectrum analyzer, storage, oscilloscope, or transient recorder, instrumentation bus, and protocols like SCPI are regional, ordinary use today. The integration into a system is done via LabVIEW, MATLAB, or Octave, or Python with a WISA library from National Instruments. Measurement RF systems in our RF check are regional dependent, or mostly an oscilloscope with 2 channels, a signal generator, a spectrum analyzer, an LCR meter. Maybe some of you have a vector network analyzer, and maybe you are a little bit common with CPI commands. Modern radio equipment has a technical concept of a direct sampling. This means not only one direct sampler, but one or more direct sampler. This means more than one receiver in the radio equipment. And where can we use it for? Well, we can use it for diversity receiving, for predistortion, mechanism for the transmitter. All modes are included, including digital voice. Have a look on the new outcoming systems on the market. They don't consist of digital voice, but they have some APIs or so to connect the digital voice system, like FreeDV. The user interface is under development all the time, but the user interface now for the modern radio equipment is a touch panel, decreasing the number of knobs. If you need some knobs, you can get them with a disc jockey console. Last year we had a talk about using this for a contest station. Very important, I think, is that we can now use the touch panel for tuning. So we touch on the waterfall where we want to tune to, and it's working with modern radio equipment. So let us have a look if we can obtain this. Red-Pitaya in detail is first a short step. It's a Xilinx FPGA, the sync series 7010. It's a system on a chip. This means an FPGA, a free programmable gate array with thousands or more than 10,000s or 100,000s gates, and a dual core ARM A9 which can be driven by Linux. This is a very efficient concept. When you put on the USB on-to-go Wi-Fi adapter, you can obtain Wi-Fi, a router function, and the Ethernet connection. The sample rate of the Red-Pitaya is around 125 megasamples per second with 14-bit, 2 channels. Usable frequency range, therefore, is 0 to 62.5 megahertz analog. We have 2 outputs and 2 input. This is a measurement device. So you have 2 generator outputs. You have 2 channels for input measurement. Additionally, we have 4 slow AD converters and DA channels, less than 1 megasample per second. We have an I2C bus and an ordinary GPIO parallel input-output. A new class of radio rig arises, to my opinion. It's a direct sampling system at the antenna, fast FPGA for the first stages of signal processing, reducing the processing rate in the FPGA, and further signal processing will be done by slow hardware, maybe the dual-core ARM. The dual-core ARM A9 are operating with a few hundred megahertz, and they are doing everything what we use with the ordinary audio processing. Okay. The last thing is that the GUI, the graphical user interface, should be touch screen or tablet, and I can show you one. I have prepared, just starting the system new, and here I have a small Android tablet, and if everything works fine, I can show you later on the HPSDR on this system working. Well done to the HPSDR group. They prepared it, and we can use it with the Red-Pitaya as well. Let me give some examples of the generation direct sampling systems. These are the Elat Duo, the Elat FM Duo. It's introduced in 2013 to 2015. This one is 2015 introduced. And you will find they are always operating small bandwidth in the application. Since you can talk with the radio, you can have CW, or this one has a modern digital mode, RTTY. Yeah, it's so 80s, isn't it? And well, but they have a wider frequency range in a panel, so you can see the neighbors on the frequency. They have always poor knobs. Have a look, only a very few knobs, and have a look here, only a very few knobs. So the ordinary view we had in the past of the transceivers, which have hundreds of knobs. This is the main difference now. And here you see a further step, less knobs, working with more or one or more DDS systems. New products without physical user interface. You don't see anything as a classical user interface. Or look at the QSR1, which is very well known to the reverse beacon network people. There are no user interface. It is done always via network. Let us have a short view on the improve of transmitter linearity. You see, this is the ideal input to output transfer curve. And you know, everybody who made a linear amplifier know that this is not the truth. the truth looks like this one. Yeah? And the very simple trick is that we add another, we add a correction system to it. We multiply this correction with the real curve, and if everything works fine, we get the black one. See, this is an ordinary transmitting, receiving system. You see the transmitter with a power amplifier and a relay connecting the antenna to the receiver or the transmitter. And we add one channel with the many receivers we now have of the DDS systems. We can add a lot of receivers to it, what we have in the FPGA. We can use it. And you see the second receiver is receiving the output of the power amplifier and feeding it back to the transmitter. And this is a predistortion trick. Here you see the predistortion which is measured with the Red-Pitaya with OpenHPSDR software. And you see the output with about 10 milliwatts. Yeah? It's not too much. But you see, this is the ordinary 7 megahertz signal with a two-tone test of the HPSDR software. And, well, this is with. And you see a big difference. Yeah? We don't like now to count the decibels, but we see it's a lot. And it gives us a very good impression what can be done. There are people who think, well, it's not too good to have such a pure signal because the neighbors don't notice you. Okay, this is the next step, the HPSDR emulation in the Red-Pitaya is done by this circuit diagram. You see two receivers here. As we need for the HPSDR, only two receivers, yeah? And this is a transceiver part, and here you see the CPU. It's from Pavel Demin of his website. And, well, let us have a little demonstration now. I switch out my system. I will show you how to enter the system. I have to... this is my Red-Pitaya. It's laying over there. You see where the antenna cable ends. My idea is the transceiver has to be where the antenna cable is ended. And the operation area should be start where you feel well, very well. Yeah? So we have a cut between the transceiver and the user interface. And this could be done by a network, by Wi-Fi, or anything you need or you think. Well, I just start, this is a web interface, I just start the HPSDR. This is the first, I should go back to show you first. I should start a spectrometer. The spectrometer shows you one channel, and you see the spectrum, which is now coming from the small loop antenna, which I have there. Well, we see it's a spectrum which can be here from 0 to 60 megahertz. When I scroll down, oh, sorry, did it, yeah. You see, it's, and we have a waterfall diagram of this. Well, okay, it's of power line and something like we have here, yeah? It's not a real antenna. Okay, and I go back, and you see the switching is very, very quick. I can switch. My system is just a system, one system. And I use is at a measurement device, and I use it as a radio rig. And it's just switching in within milliseconds. If you do it with a script, it's done with milliseconds. Now I open the HPSDR, and I use my tablet here. Hopefully it's working, yeah. takes a little time. Can't see that now. I have one Metis interface. Just try to start it. Maybe it's working again. Yeah, no, it's coming up here. It's coming up, and here you see the Metis interface, and it is of my RedPitaya over there. You hear the network is not very clean, so we have some interrupts in it, since it's transmitted via UDP, and the UDP is sometimes not so good. At the moment, the network is not very stable. You can hear it here. Yeah. This is not a good demonstration of it, yeah? I know it. But of course we can have it, yeah, okay. So I showed you both the RedPitaya as a measurement, the RedPitaya as a radio rig. Thank you for that. Now I have to leave it here. Okay. So go back to my foils. I showed you a little bit about, this is using OpenHPSDR for Android. We can have it for Windows, or I prefer for Linux using Quisk, very nice software with included digital voice for HF. This is very important to use FreeDV inside. Okay, something about the community. Here we see from Jörg, DD8JM, a concept of a transceiver. With the RedPitaya, you see a very small element, and these elements can be found on eBay or anywhere else. Put them together and you have a full-size transceiver with about 50 watt output. And if you have the idea to want a kilowatt or a little bit more, WSPR, and this one is 2 AD converters using 2 antenna inputs, and we can select the green or the blue one. And we have 8 receivers at the same time, reducing the 125 megasamples in this area down to 3.2 kilosamples at the end. And we see a WSPR decoder, a bash script control, and putting them up on the internet. This is very well known to the WSPR community now. And in my talk in the afternoon, I show you a little bit more about it, if you are interested. I should give the link to Pavel Demin's GitHub page. You find a lot of flashcards, which you can download, put in, and you have a starting system. There's nothing to do than to make a flashcard, to put it in, to parameterize, and then it's working. And you find the SDR receiver or the transceiver with HPSDR. Well, remember, change will be done within milliseconds. You see the VNA, the oscilloscope, the spectrum meter, the SDR, and you can throw in milliseconds. Let me conclude. The RedPitaya was shown in detail. The RedPitaya as a radio rig. We have seen a small demonstration with OpenHPSDR emulation. You can change it within milliseconds, and the community projects RedPitaya SDR have been introduced. Any questions? Yeah, I just want to give you the microphone.
Actually, on the RedPitaya forum, I saw a modification to use external clock generator for RedPitaya. Yeah. Have you tried it?
No, I did not. Okay. But there are now the RedPitaya people who can, maybe, they can give some more information about that. Please use the microphone, please.
Yeah. If you go to our wiki page, there is an example. You have to replace 2 resistors, and you can bring the external clock. And there are companies that did that. I think it was for spectrometry or something.
But for that, you have to remove the heat sink.
Yes, it's true. Yes, it's true. But it's easy. It's easy if you just, you will not damage anything. So.
And I have another.
Sorry.
That's a technical question. Okay. As far as I know, okay, Hermes for poor signal do a down conversion from the digital output to the D converter, okay? And I haven't seen on this additional down conversion on the block diagram. Do you use this additional down conversion or emulated in the ARM software or how it's work?
Short answer.
Yes, so basically regarding the software-defined radio, I suggest that you ask Pavel Demin because this is his project, let's say, and he knows better than we, so.
Okay. Any more questions? Okay, thank you very much.